right. Next up, I want to give big thanks to, it says here in the notes, thank you so much to the Clear DLF, and especially to Sharon Ivey for continuing to be our fiscal host. Big thanks to Jennifer Cummings and Kathy Azevedo of Concentra, as usual, for doing an outstanding job supporting the conference for many years now. So, all right. Sponsors. We cannot make these conferences happen each year without our sponsors. So a big thank you to the following organizations that have helped make it happen this year. Our platinum sponsors are Blacklight and OCLC. Our gold sponsor is EBSCO. Hey, fun fact, if you work for EBSCO, every Christmas you get pecans. Our silver sponsor is Innovative Interfaces Incorporated, about which I will say no more. Our bronze sponsors are University of Illinois at Urbana-Champaign, Rutgers, Pennsylvania State University, University of Michigan Library, Johns Hopkins Sheridan Libraries, Developers for Diversity. And our contributing sponsors are the University of Pittsburgh Library System, WNYLRC. I have no idea what that stands for. I'm sorry. So I figured something to do with New York. Let's go with that. University of Illinois School of Information Sciences, Princeton University Library, Rice University, Spring Share, Digital Public Library of America, and Data Curation Experts. All right. Thank you to our sponsors. Now you applaud. Anyway, I have rambled on enough and I am past my time, so I am going to turn it over to Aviva to introduce our keynote. Thank you very much.
I am going to just take just a minute. Again, welcoming all of you to Buffalo. For those of you who are not aware of where the name Buffalo actually comes from, we did not once upon a time have buffalo roaming the streets of the city. We are actually named after the rivers that are here. It is actually Beau Fleuve. So if you speak French, you'll understand that that means beautiful river. We have a few of them, and we also have some lovely falls just a little bit north of here that I hope all of you have a chance to see while you're eating our awesome food and seeing examples of amazing 20th century architecture that Buffalo is home to. We are, as I said, very excited to host you here. This has been almost 3 years in planning. Francis actually approached me about day 2 or 3 of my time here at UB and asked if I would be willing to host. Yeah, Francis, I gave you a call out. There you go. So for those of you who don't know me at all, you may not know that Code4Lib is also where I came from. So this community, these people, this group, this meeting is part of why I am a vice provost now today. So in 2005, the very first Code4Lib meeting was held in a small conference room space at Oregon State University, which is also where I worked once upon a time. My very first Code4Lib meeting was in 2012 in Seattle, and it totally changed my life. Dan Chudnow, who was one of the very first people who started Code4Lib, was the keynote speaker that year. And that was also the very first year that Code4Lib was not able to allow everybody who wanted to attend the meeting to be able to come to that meeting, which meant that there were people who had started Code4Lib who couldn't be there that day, right? The registration was just capped and that was it. And it was a watershed moment for our entire profession, right? Because before then, the IT folks were kind of stuck in the basement, 1 or 2 of you, kind of sitting there doing your thing. And from 2005 to 2012, right, there was an explosion of people doing this work and an explosion of people impacting our profession. And we are all here now because of the work that all of us have done to bring us here. And this community means a lot to me. And so having a chance to be able to host again, because I also hosted in 2015 in Portland, for those of you who were there, this means a lot to me. So welcome all of you to Buffalo. I am so happy to have you here. I am filled with emotion right now. And it's really great to see everybody in person again. So thank you for coming. All right, so with that, I'm going to stop my bloviating and I'm going to introduce our keynote speaker and get your day started and get y'all into what you really want to be here for. So our keynote speaker is Crystal Lee, who is a PhD candidate at MIT, a senior fellow in responsible computing science at Mozilla. Her work investigates what she calls the life cycle of data representations, or the process by which data sets are curated, cleaned, visualized, and circulated. In other words, she works on a wide scope of things, from the history of disability and human-computer interaction to theories about data visualization. This research has been supported by fellowships from the National Science Foundation, Social Science Research Council, and the MIT Programs for Digital Humanities. She is also a research affiliate at the Berkman Klein Center at Harvard, where she co-led the Ethical Tech Working Group. Previously, she has worked as a visiting research scientist at the European Commission and graduated with high honors from Stanford University. So with that, I pass things off to our keynote and welcome all of you once again to Buffalo.
Hello, thanks so much for welcoming me to this incredible venue, and thank you so much to all the folks at the Code4Lib conference team, especially Margaret Heller and Ken Irwin, who've made this event possible for me. And I'm especially grateful to you all for allowing me to present this remotely. And please know that I wish that we might meet in person one day. And in the interim, please, please, please contact me on Slack, Twitter, and email, because I would love to hear from you. So for the next half hour, I want to meditate a little bit on the intersections between access, care, and data justice, informed by some of the projects I've been working on at Mozilla. And I'm highlighting access and care and data practices partially because I'm really excited about this opportunity to speak to folks who are perhaps the most well-versed in all of the communities that I know about these topics. And every time that I mention to someone that I'm talking to a group of social justice-oriented librarians who code, I am elated. But specifically also because I hope that you might help me refine this thinking further or tell me that I am wrong entirely. So when I think about justice and equity in computational systems, I inevitably turn to the great disability justice activist Mia Mingus and the way that she talks about access intimacy. So she says that at first, access intimacy is really hard to describe. It's a kind of feeling when someone just gets your access needs without need for explanation or to be excessively vulnerable. So you don't need to justify your existence in order to get what you need in order to thrive. And the other people around you are conscientious about how these power dynamics interact within a group of people. And it's this form of intimacy and care among multiply marginalized people that is liberatory, precisely because it helps us and lets us be our whole selves and to be interdependent on one another as we help navigate through structures of oppression. And as Mia Mingus says, it's less about identifying ableism or racism and more about finding people to fight it alongside you. So in this sense, access intimacy is about interdependence and community building.
Excuse me, Crystal?
It's about imagining.
Crystal?
Yes. Hello? Should I continue? Okay, I'm just going to continue since I don't hear anything else. Okay. So yes, access intimacy. It's about imagining a collective future that centers justice and equity and figuring out a way to build towards it together. And in many ways, access intimacy is one corrective when I start thinking about the ways that computing culture and tech development has really failed us. And it's about both collective action and attention to difference. So I'm going to return to this concept at the end, but ultimately in this talk, what I really want to focus on is bringing these concepts from disability justice activists into conversations about information science and computing And to do that, I'll try to think through some of the different ways that folks have thought about addressing injustices in data collection and tech development. So the problem formulation about this kind of stuff usually goes something like this. So computing culture and tech development reflects or often exacerbates existing social inequities. And there are lots of examples that we could point to here, like the use of surveillance to incarcerate people of color at higher rates, or forms of computational phrenology that attempt to identify things like gender, emotion, or attention from facial data. So there are lots of historical reasons for this, which have been documented very extensively by historians, anthropologists, and beyond. So, for example, there is the legacy of the military-industrial complex on technological development. It's about the environment of deregulation, which often is paired with a ruthless focus on efficiency or disruption as standard technical practice. It's also about toxic masculinity and the gendering of technical work, and a kind of techno-saviorism as a corrective to long-standing social ills. So I'm thinking about hackathons to like solve for poverty or to solve disability. But I find that a lot of the exciting work that addresses this central problem, both in terms of analyzing the problem and suggesting new solutions, falls in one of three categories. So refusal, regulation, and remediation. And I've kind of created these categories as a way for me to organize my thoughts and hope that it might push your thinking forward too. And I know that they're often overlapping concepts, but they're still helpful for framing these different interventions. So what do I mean by them at a high level? So at its best, refusal is about fundamentally resisting computational systems through collective action. And I'll talk through the intersection of refusal and access, particularly when it comes to the social cost of refusing to use or build technology. In regulation, I'm thinking about legal and legislative forms of recourse to current and anticipated harms, particularly as it's brought about by forces external to the tech industry. So here I'm definitely thinking about the work of our distinguished closing keynote speaker, Lauren Chambers, along with the fantastic work of folks like Ben Green and Tom Zick on crafting safe and equitable policies around the adoption of computational technologies. So I will say I'll speak the least about this section and defer to others' expertise. But finally, with remediation, I think about the different ways that we might reimagine pedagogy and tech development. So integrating interdisciplinary perspectives into computer science education, or through alternative approaches to making new technologies like design justice or data feminism. So here I'll talk a little bit about the Responsible Computer Science Challenge at Mozilla and the ways that our initiative succeeds and fails within this framework. And I think that analysis about the ways that technology fails us is fundamental to how we think about resistance, but I also want to propose ways to mobilize that critique to make it a constructive endeavor that targets even the most skeptical of software engineers. So the question to me really is, like, even if you convince that skeptical machine learning grad student or software engineer that algorithmic harms are real, what do they do when they go to lab tomorrow? And similarly, who gets to refuse to build or use technology? And additionally, since the problem is rarely as easy as simply saying no. So I think when it comes to refusal, a lot of the guiding principles that I'm referring to here are enshrined in things like the Feminist Manifesto, along with a really broad swath of human-computer interaction and design scholarship on anti-racist intersectional non-intervention. And part of that is distinguishing between individual and collective approaches to refusal. So a difference between, say, refusing to use plastic bags at the grocery store as opposed to a more collective approach to thinking about environmental harm. But here I also think a lot about what technology does when it under and over promises. So Ben Green talks a lot about how technology does both of these things simultaneously. It, in one sense, overpromises by talking about how technology can solve all sorts of social ills, but also underpromises in the sense that this kind of rhetoric forgoes the opportunity to radically rethink the social infrastructures in which this technology is embedded. But finally, when it comes to refusal, I think there's a lot of learning that we can do from disabilities to think about access as process and not simply as a matter of compliance. So, like when I think about refusal, often the catchphrase is when the implication is not design. So here I'm thinking about the work of folks like Lily Irani, Anita Sechan, and Paul Durish. So here we're thinking about like whether or not people can afford to opt out of Facebook and Google, since all of these kinds of things take time, resources, and effort in order to maintain like a completely separate search and storage infrastructure, and in order to maintain your social relationships. If everyone is on Facebook or Twitter, like how do you maintain the same kind of social ties when it's so much more difficult to see each other in person? But even if you can shoulder all of those social costs, often do you have the expertise and privilege to navigate this process of refusal? When it comes to being at the airport, at TSA inspection, like, do you have the expertise to know what exactly to say to the TSA agent in order to opt out of the process of walking through the scanning machine? And more simply, I would say, like, especially in a place like New York and Central Park, like, how do you opt out of taking a walk? I think these are like forms of privilege that I think can often go unsaid or can be unexamined. But here, there's really a double bind of participation. So for example, like people of color or disabled folks might reasonably opt out of training a surveillance system. But often this also means that, you know, when I go into a bathroom with automated sinks, like sometimes it doesn't work quite as well for me as it does for my white colleagues. So what are the consequences of opting out versus opting in? And what kind of compromises are you willing to make? So I think there are a couple of different dimensions of refusal that I think are useful to think about. So Jonathan Zung and Nate Matthias have done really interesting work on this that kind of separates it into autonomy, power, and time. So like, is it an ongoing form of data collection, or is it a one-time affair? When it comes to power, are there different kinds of barriers or costs to individually or collectively opting out? And finally, with autonomy, like what kind of decisions are you able to make, and how can you aggregate, or how can you think about aggregate uses of data in society? But when it comes to like specific examples of what refusal can look like, it can be all manner of things, like from class action lawsuits, this kind of large scale collective action, to everyday acts of refusal, like sharing Netflix passwords, sabotaging crowdsourced data, or leading things like expert testimony or advocacy. I particularly like the sabotaging crowdsourced data example, simply because like sometimes it's so interesting and funny as to be almost unbelievable. So I remember seeing, I think this was on Reddit, like a man who has a wagon full of like 90 or 100 cell phones in order to kind of simulate traffic jams on Waze. So, I mean, I think in terms of thinking about refusal, I'd also pair them with stories about disability and technology as Ashley Hsu talks about them. So in terms of the kind of tropes and genres she's talking about, there is techno-ableism, where there are narratives about technology and disability that reinforce ableism, often by fixing people with technology. There are tropes like the pitiable freak or the bitter cripple, or the inspirational overcomers as people who like technology might be modeled for. And I think there are also narratives about the purported user and the assumed designer. that also play into this entire framework, in the sense that there are some people who are allowed to be users and some people who are never considered a designer in these systems. But ultimately, I think it's about a failure of the tech imagination, like a failure to recognize the structures in which disabled bodies operate, and a failure to imagine different ways of existing. So what are some examples of refusing to build and using oppressive technologies? So the first, I think, which is the most obvious, is listening to disabled experiences and refusing ableist narratives. To think about the difference between individual consent and collective refusal, to be intentional and nuanced about who gets to participate and whose participation is valid within a technological development system. And I think as far as work that I really look to as examples of this, I see Dee Wu's anthropological work on disabled folks training Chinese AI systems, and Liz Jackson's work on moving away from disability dongles. So let's come back to reimagining pedagogy and technological development. So this is the work that I mentioned earlier that I do at Mozilla, directing the Responsible Computer Science Challenge. So we have like a pretty corny, but I think true tagline: with great code comes great responsibility. And like the Responsible Computer Science Challenge is ultimately a grant making and community building program. So it, in the last 3 years, we have dispensed $3.5 million to a number of grantees, which has resulted in 15,000 students attending 100 distinct classes about responsible computing across faculty in like computer science, the social sciences, law, arts and media, so on and so forth. And I think what's exciting about like all of this programming is that it actually produced something called the Teaching Responsible Computing Handbook, or playbook, sorry. And what the playbook is really about is to think about what are ways that you can actually implement this kind of thing at your university, rather than like, here are specific modules that you could teach in a class. And beyond the playbook, we also have a global community of practice that is trying to promote collaboration and cross-disciplinary insight on issues related to responsible computing. I will link to both the playbook and the community of practice, which you can sign up for in the Code4Lib Slack later. And we also have an annual Teaching Responsible Computing Summit. So coming back to the playbook, I think what's exciting about this work is that it's really a how-to guide on how to implement teaching responsible computing. So from things like institutional sustainability, like how do you make the argument to your dean or to your department chair about baking this into hiring, promotion, and tenure processes? Like, what does it look like for accreditation or your course requirements? Like, how is it that we can make responsible computing a sustainable part of the curriculum? We also have modules on cultural change. So how do you facilitate these difficult conversations in the classroom with and talk about things like diversity and equity? Like, what are some effective talking points for different audiences? And ultimately, how do you manage resistance from more old school faculty members? I think there's some other interesting topics as well, like assessment. So how do you think about learning outcomes and evaluating student team dynamics? How do you work across disciplines and work across institutions? And my favorite part, how do you engage beyond the classroom? So can it be integrated into things like service learning, internship, employment choices, or engaging with industry? And I think this is all part of like a broader strategy at Mozilla, which I'll talk about here, which is technically called the AI theory of change. So I think there are a couple of different ways that we can think about change. So there's things like shifting industry norms, which the Responsible Computing Challenge responds to, thinking about ways of building new technology and products. So like training people in more holistic and interdisciplinary ways to think about the product development pipeline. but also it's about generating demand. So creating informed consumers who will then be able and willing to support things like regulation incentives to make responsible computing and more of a reality in ways that center both agency and accountability. But so what are some of the promises that I think this kind of approach takes? So I'm really excited about the way that the Responsible Computing Challenge, which I'll call RCS, challenges the false distinction between social and technical training. I also like that it encourages a kind of reflexive design to consider who benefits from technology. So kind of calls back to some of the work that I talked about when it comes to refusal. But more broadly, I think it can contribute to cultural change that helps students identify and redress historical inequity. But I think this approach also has a number of limitations that I think I'm still trying to think through as we enter the next stage of the program, since we're expanding more domestically, but also thinking about how to scale RCS to different geographies, namely East Africa and India. So just kind of at a bare minimum, the limitations include relying on a deficit model and a hierarchical understanding of tech ethics. So it fundamentally assumes that students don't have these skills, or that these skills just are non-existent, and that it can be something that teachers on high can teach students as like a very singular transfer of information. Also doesn't necessarily correct for or address power dynamics within the workplace. So a student can be 100% on board with everything that they learn in responsible computing curricula, but once they leave, they're still the most junior software engineer. And how do they bring up those kind of ethical concerns in ways that will be taken seriously by their leadership if that's not already a kind of thinking that the startup or the company that they work at already provides. So, I mean, I think in this sense, like, it's very striking to me that in a lot of responsible computer science curriculum, and this is a point that was brought up to me by a bunch of students actually, is that they want to know what the actual steps are for them to accomplish if their boss tells them to do something bad, or like what are ways to actually whistleblow, and what are ways to organize people within the workplace. These are not usually, I think, components within this kind of curricula, and so it makes it very difficult for it to correct or address these kind of power dynamics. But more fundamentally, it kind of individualizes the problem, and it forces students rather than corporations to shoulder these ethical burdens. So let's come back to access intimacy. I think fundamentally, this concept is about finding and nurturing a community of people who are directly challenging ableism and racism, to understand the relational aspects of access, to imagine a better world outside of simply remediating the one that we have now. And collective action through refusal and pedagogy are two approaches that I think we can contribute to access intimacy, but only if it's shared work that centers the most marginalized people. And as Mia Minga says, the power of access intimacy is that it reorients our approach from one where disabled people are expected to squeeze into an able-bodied people's world, and instead calls upon able-bodied people to inhabit our world. So I think both in my work at Mozilla and at MIT, I often think about like the promises and the limitations that I as an individual can do when faced with these like large scale systems, because I know that an individual can't instigate or be responsible for systemic change. And I think one of my colleagues at Mozilla said it best when I approached her with this, and she says, it's true, no individual organization can change the status quo because oppressive computing practices are systemic. But I think our challenge is to coordinate shocks to the system and empower others to do the same. And I very much look forward to being in community with you all in hopes that we can do exactly that, coordinate shocks to the system. Thank you very much. Hello, I just joined the Code4Lib channel, thanks to Andromeda, shout out. So I'm I don't see any video or hear anyone, so I'll just take questions there. Yes, okay, so the first question, can I talk about some approaches that we might take outside the classroom as librarians and tech people to support students? I'll actually answer that with the second question too, because I think they're related. Tess says, you talk about your responsible computing classes as being top down. How can you bring in students' existing experiences? Okay, so I think one thing that has been really exciting for me, talking to a lot of students who either are in, like have participated in responsible computing curricula or are, very actively doing this kind of work outside of school, is that they have all sorts of different kinds of output. They have zines, they have reading groups, they have, advocacy organizations that have podcasts. I mean, I feel like with so many of them, they are so professional that like, it kind of boggles the mind. Like I have definitely been treated better and actually been paid by student organizations more so than like many professional organizations. So I think in terms of supporting students, I think it is the work that like librarians have been doing from day one, which is helping them find the information that they need and supporting them in ways that faculty do not. So I think it is about helping facilitate a lot of that kind of student institution building. So supporting their zines, podcasts, etc. But also about like supporting and uplifting student activist efforts, often to challenge more senior faculty members. I feel like, especially in certain universities, I will keep it anonymous. I think there are faculty and staff who are allies, and they are the ones who uplift student perspectives in order to make sure that their other faculty colleagues are also in line. And so I think creating a space for that kind of work, both institutionally, like a physical space, as well as an intellectual one, I think is definitely the role of a library. Yes, so the next question, do you have any thoughts about the origins of systemic oppressive culture you discuss and how much of it is corporate culture versus other factors? Yeah, I think, I'm trying to be like intentional and nuanced about the answer, because I think like I can very flippantly say that I think the origins are capitalism. Oh yeah, no, capitalism bad, according to Leica. Yeah, so origins of systemic oppressive culture. I mean, I think the interesting like historical point about the military industrial complex is that like it's something that is infrastructural and state driven that then becomes corporatized. And I think so like the move from like oh my god, sorry, the move from collective responsibility for infrastructure. I'm so sorry. She is trying to shock the system. I apologize, Alistair. I will come back to the answer when I remember it, rather than try to like really try to remember, because then I will forget. So sorry. So Mike C asks, what are some ideas to start shocking the system? And there's some replies that are like, get a dog, apparently, let Leica loose on the system. I definitely agree. So I'm going to try to combine this question with the next one, which is balancing supporting broad efforts. How does one balance supporting broad efforts to perhaps improve student ability to question and pressure faculty with some popular movements to also pressure faculty and institutions in ways that may be considered less desirable. Okay, that could Dan's Purple Heart elaborate a little bit more? I think I don't quite understand. I do really appreciate though that all of these questions are like, they start and end with a question mark, and don't have like a long paragraph before them. So I'm gonna try to think through that if people have other questions or if Dan's would like to further elaborate. Oh, yes, thank you. David also asked a question. Does the student-focused approach kind of kick the can to the next generation? Are there approachable system shocks that we could do now? Yes, I agree. The student-focused approach does kick the can to the future. And I think it not only kicks the can, it like asks them to shoulder that entire responsibility as if like there's no responsibility today. As far as like approachable system shocks we can do now, I mean, I think a lot of the students are like having the conversations, pushing tech companies to do better, like both in terms of I'm so sorry. Are there approachable systems shocks that we could do now? Yes. And I think the answer in part is by listening and advocating for disabled people and other marginalized folks, speaking up against the tech to prison pipeline, which is very much happening today. So call your congressman about all of the different like increasingly expensive communication systems that are happening in prisons right now, like, you know, pay to play email, pay to play iPad, video calls, that kind of thing. So I think there's certainly like discrete topics and causes that we can think about that individual people can take up within these larger systems of collective action. Oh, I see. Okay. Yes, exactly, Max. Even plain old telephone in prison can be prohibitively expensive. I'm going to circle back to Dan's question, but just because it's right above Max's, Bo-Hyun Kim says, would the false distinction between social and technical training apply to the library context too? If so, could you tell us a little bit more about that? So, I mean, I think in computer science, when I think about the division between social and technical training, I often think about like the way that we teach algorithms or like if-then statements or sorting algorithms as if there's something that are like purely mathematical problems that you solve on your computer, and that absolves you from all social responsibility beyond that. And I think having exercises like the one that Evan Peck at Bucknell has created, and he, I know, collaborates a lot with the librarian Diane Jakaki. So like really interesting like collaborative effort between like computer science librarians and humanists there. So he, in the section, I think, on sorting, in his intro computer science class, asks students to essentially create a hiring algorithm to cull resumes. And I think like the ultimate exercise in that particular homework is to show that, you know, even if you have mastered the so-called technical content, like it doesn't, you're still going to be faced with a bunch of social, you're still going to be faced with like social context and social issues. So like, how do you think about both of those things in tandem? I think Would it apply to the library context too? I think absolutely. So if I'm thinking about like search and discovery algorithms, or even just like classification, I think that in and of itself is something that straddles the social and technical. So I'm thinking about things like Maori library classification systems, or I had another system that I can't remember off the top of my head. But like, I think there are different ways of classifying information based on where you sit in the world, and being able to kind of meld between the two and talk about how like classifying information is not a fundamentally objective act is where I'm trying to get at here. Yes. Oh, I just saw the response about cataloging rules and subjects. So I'm glad that we're all on the same page there. So to follow up on Bohyun Kim's question, should we be training people to look at questions of should we apply a technical solution at all? Oh, absolutely. I mean, I think not designing is also, or not designing or not developing something is also a form of development, and like it is also a credible and useful answer to a lot of these kinds of problems. Okay, time for one more quick answer. Link to Maori library classification. Will definitely send something about that on Slack. Otherwise, I think that's probably it. I know that my time ends at 10 a.m. Great. Thank you so much for these fantastic questions, and thanks for bearing with me. And yes, I can share my slides. Thank you so much.
Oh, good morning, everyone. We're really happy to be here. It's early for us, and so we hope to get an idea of who's in the audience today. And so if you don't mind taking this short poll, we'll get started with that. It's a bit.ly link. It's 2022 AB FAM. So thank you so much for coming. We're here to talk about algorithm bias and a little bit about who we are. My name is Sherry Fu. I am the engineering librarian at California State University, Los Angeles, and I'm joined today by my collaborator, Shalini Ramachandran, and she's a STEM librarian at Chapman University. A few years ago, we were both science librarians at the University of California, and we started our algorithm bias study there. We're part of an algorithm bias research team, which also includes USC librarian Karen Howell and Boise State University computer science faculty Steve Cutchin. So at USC, we heard a talk by Sophia Noble and on algorithm bias, and she starts her, and it inspired us to read her book, and she starts it with the harms of bias and ends it with another example at the end. So the first example she gave was of gender and racial bias in the search results she found on Google after she typed in the search terms Black girls when helping her daughter with her homework on Black role models. The top results that came up were pornographic and offensive. And the clicks of users, along with prioritizing paid advertisements, meant that bias and disturbing representations of Black women were replicated online in Google. Noble concludes her book with a story about Candy, who owned a small business, and she was running her neighborhood hair salon, specializing in haircuts and styling for African Americans. Candy's neighborhood was changing quickly, and advertising online and having reviews on websites like Yelp became increasingly important for business. Candy, however, didn't have the funds to place ads in Yelp or Google, and as a result, she lost her clients and eventually had to close her business. So these were pretty clear examples of algorithm bias and how impactful they are. In our work, we began to understand algorithm bias, and we wanted to find a definition, and this one came to us. Algorithm bias occurs when computer algorithms systematically discriminate against certain content, individual, or groups in favor of others without a sound basis. We were led by Steve, and we came up with this definition because it uses plain language and really hoped to encourage thoughtful conversations. So also Friedman and Nissenbaum in 1996 also contributed to it. So because computer science students will be entering the workforce and shaping the future of algorithms that drive automated systems, we decided to develop instruction on algorithm bias awareness for computer science students. So we've taught sessions at USC, Cal State LA, Boise State, and Chapman University. And most recently, we taught at Cal State LA and Chapman. And some of the questions that came up during the discussion were, why has algorithm bias become a hot topic when other issues of discrimination still remain? If a review board is established to review AI products and companies, won't a board that lacks the diversity replicate biases? And lastly, if an algorithm is fixed for bias, isn't that a superficial solution? So these questions really point out why algorithm bias is dangerous and difficult to root out. So another work that we really enjoyed or found insightful was Kathy O'Neill's Weapons of Mass Destruction. And she writes pretty succinctly and clearly about why it's dangerous and difficult. It all falls under the umbrella of automation. And so you'll see that you probably all know that traditional software is hand-coded, written line by line, and an algorithm that sorts names alphabetically is explainable. These machine learning algorithms look at raw data and they create modules. And there's lots of distinctions. A lone decision-making module or algorithm can created with a decision tree or linear regression is explainable, right? These deep neural networks are different. They're from the transparent algorithms. They analyze thousands of cup images, for example, and develop and create statistical models to identify cups. This means that developers don't really know how decisions are made, and they can't review different parts of the algorithm as it's created. And so depending on what data is fed to it, you could have a huge preference for cups of coffee as the preferred cup. Another way of saying it's that these big data processes codify the past, right? It creates a feedback loop. When algorithms start to make problematic decisions, this behavior generates more erroneous data, which in turn further hones the algorithm and causes even more prejudice, and the cycle kind of continues and it grows upon itself. So it speeds up the execution of bias and exacerbates it. When we see that automated algorithms apply to large groups of people, the negative effects are encoded, and so the scale of the model is really pervasive and vast. So if you think about recommender systems for YouTube, for Google, for social media, it grows. The old adage of garbage in, garbage out really applies. So there's different places where where bias can be introduced into a system. But one of the other considerations we have is that people, hopefully less and less, but a lot of times it's still perceived as neutral, and they don't really necessarily question the bias. And so next, Shalini will talk a little bit about what we can do about algorithm bias.
All right. As you, as Sherry delineated in her discussion, algorithm bias can be, complex and, difficult to address. So, we kind of started a discussion in our group in terms of what are some things we can do about algorithm bias. And of course, this is not an exhaustive list. If you have ideas, we would love to hear from you as well. So, minimum we can do is recognize that it is a reality, which is why we are introducing the concept of algorithm bias to computer science students kind of early in their academic life. A lot of the sessions we teach are to first year computer science students. Additionally, one could include bias reviews in software development, establish boards to handle oversight of complex artificial intelligence systems, for instance. We could require that AI or ML machine learning search algorithms provide clear explanations for the results that they produce, document their reasoning and grounds. And like we said, if you have other ideas, that would be great to hear from you as well. So in terms of the rollout of some of these ideas, generally some of them have been bumpy. It's been a slow process. So one tech company that tried to have an ethics board was Google in 2019. However, the board survived for just over a week before it was disbanded. So a main issue was criticism about the composition of the board, which included the president of the think tank, Heritage Foundation, and another member who was the CEO of a military drone company. So ultimately, the composition of the board and its quick dissolution raises questions about how effective private companies can be to exercise oversight over the systems they're creating, because essentially their interests would be corporate interests. So would they be able to have the the distance that's needed to create good policy and good review? All right, so these are some other areas that are looking promising. Professional organizations like IEEE and ACM have taken on developing standards and roadmaps for achieving algorithmic awareness. And some of these are work in progress, but IEEE actually has a standard now, the Algorithmic Bias Consideration Standard. And ACM put out a statement in 2017 on algorithms, and they have kind of a roadmap for, the steps needed to create algorithmic transparency and accountability. So first, awareness. 2 is access and redress. 3 is accountability. 4, explanation. 5, data provenance. 6, auditability. And 7, validation and testing. Systems and institutions that use algorithmic decision-making, should be able to produce explanations regarding both the procedures followed by the algorithm and the specific decisions that are made. And this is especially important in contexts where the algorithm is affecting millions of people. Let's see. And then in terms of legislation, there are some bills currently both at the federal level and at various state levels. At the federal level, it's yet to pass committee of the Senate Algorithmic Accountability Act of 2022. The California bill, AB 13, is titled the Automated Decision System Accountability Act. And this has actually passed a committee review. So we are hopeful it can move forward in California. And then in terms of again, solutions. One of the difficulties with algorithms is that most AI and ML software is proprietary information. So many of the steps that the ACM underlines, for instance, just cannot be followed because these are closed systems. They are trade secrets. They are not willing to explain their algorithm to the public. So this makes it difficult to identify why an algorithm is producing biased results. A famous example is the Compass software used in the criminal justice system, which was actually erroneously giving high scores to for recidivism based on race, which was inaccurate. So which is why the concept of open algorithms is showing promise. So one of the groups is Opal, which is a nonprofit founded in 2017 by a consortium of partners. It includes MIT Media Lab, the Imperial College of London, the World Economic Forum, and the DataPop Alliance. So again, here, what they want to do is create a suite of software. So it's similar to, open source coding. The concept is similar. So they like open algorithms to provide anonymized, secured, and formatted data. So we are hopeful that these ideas will progress and move forward and address this very complex issue. So with that, we come to the end of our presentation. Again, if you are able to go ahead and take that survey. Again, it's the same link, bit.ly 2022 ABFAM. That would be terrific. And then we welcome your questions and suggestions, of course. You can contact us by email. Our email addresses are on the screen. So with that, we end our presentation. Thank you for joining us.
All right, well, I'm going to go. Thank you. So hi, everyone. I'm Jack Hill from Duke University Libraries, where I do system administration and programming. And one of the things I administer and program on are our repository platforms. And that's led me into also working on our digital preservation working group, which is a group across the library where we promulgate guidance and policies and help us achieve our preservation goals. One of the recent guides we recently published is our guide to file formats with the thinking about to help guide our researchers and other library donors about what formats of the data they give us we think will be most useful in the future. And so the way we looked at that was to classify files based on how much effort we thought it would take to use all their features and get the data out of them and understand them in the future. And so level one were things that we felt reasonably confident about that would be useful in the future. And so we looked at what the general community of librarians and archivists thought. We looked at how common the file formats were, the nature of them, their documentation, what software worked with them, et cetera. And level two was some formats that we thought might require additional resources to make full use of in the future. The less common, less well documented, implementations aren't readily available, et cetera. And then level three, you really go up a cliff here as far as effort. And so these are things that might take significant resources. Maybe you need a grant to work on understanding them. And so this could be because they're proprietary, there's no documentation, the nature of the format requires specialized skill, very niche. So if we look at an example of our word processing formats, so things we're reasonably confident will work in the future. For example, the archival subset of PDF. We trust the community of expert archivists and technologists who worked on defining this subset. It's well documented. There are multiple free and open source implementations of it. It's very common. See also EPUB, which is an HTML-based format for ebooks. Again, it's very widespread, multiple implementations, popular enough that we think tooling will exist to understand it in the future. Things that might require a little bit more effort. The full range of PDF. PDF is a huge document standard with many twists and turns. If anyone at a future Code4Lib conference would like to give a talk about all the little dark corners of PDF, I'd be most excited to attend. But for instance, one thing that makes PDF nice is that you can embed fonts, and so the display looks as the author intended. Well, this also means that you can store arbitrary, it supports storing arbitrary files. So it could be used as an alternative to like zip, or as a whole file system you can stuff in a PDF. Clearly, making use of that full range of features in the future may not be supported by all PDF software implementations currently, and so some niche feature might require additional development. Looking at the other two formats there, rich text RTF and the XML current Microsoft Word format is less popular, not as well documented, but they're text-based formats. So any particular piece, a general computer technologist would be able to look at it and probably suss out, make sense, maybe do a format migration. Then we go up this huge effort cliff. We have the older binary Microsoft Word format, which could definitely not standard, could vary between versions of Microsoft Word, and requires some specialized skill in working with binary formats that are less common than working with text formats to understand. And then even things like Google Documents, where when the libraries don't even get access to the original format for the store. So then if we look at what our recommendations are for software, it's a little bit embarrassing. We don't have any sort of software at the current time that we think will be reasonably likely to work in the future. And not only that, we had attached a warning that we weren't even able to do a full analysis. It was just, the field of play was just too complex. But we think that having the computer source code available means that we could get it working with some effort, but if all we have is compiled or binary executable files, then we're up at the, maybe you need a research team and a grant to really make sense of this. And is that important? Yeah, I think it is. One of the criteria we were looking at to define these different levels in the file formats was the availability of software implementations. And if we're not sure about whether we can get the software implementations to work in the future, how sure are we about the formats? And we also, every time I looked at implementations, it was always tied to the software that implements them, in addition to characteristics of the format itself. For example, we also have formats that are software. So this presentation that I'm presenting, I'm using PDF slides, but I didn't author the PDF by hand. I used a markup document typesetting system called LaTeX. And so I get a textual file, which I edited, and then used, so that sort of looks like software. It has branching statements and assignment statements and whatnot. And then there was also a compiler interpreter that read that file and then produced the PDF. But so that's just one small part of it. At Duke, we also have a repository for research data. So this is where Duke researchers can store their data, and they can cite it when it's in there. And the libraries will provide some sort of caretaking of it for future resources. So having a brief look through that research data, I found 3 different items we had in there that had some interesting software preservation questions going on with them. So one was the set of data, and it included the scripts they used to produce the visualizations from the data. Well, that's great. It's all in one place. But unfortunately, the scripts were written in MATLAB, which is only available as proprietary binary software. So getting MATLAB to work in the future, we might be on top of this huge cliff. There's another project that we didn't actually even have the software in the repository. It referenced an external source. So unless we did work to capture that, could be lost. We had another thing that was could be free and open source software that we could put in the repository, but what had been included by the researchers was the binary artifact that they had actually run on their computers. But I don't just work for the library. I also am a technology hobbyist, and one of the most exciting project I worked on is GNU Geeks. Yes, it's pronounced like that. Well, we're sort of clever, but also it's a community that's multilingual, and English isn't even everyone's first language. That it started up in Europe. But it's a package manager. So if you think of a package as sort of like a unit of software you might work with, a program, a library, that sort of thing. So it's both the tooling to work with these packages and a large collection of packages. You can use it to build entire operating system images or container images. That's what I'm using today. But it's a Linux distribution. But it is a little bit unique. The community has a focus on software freedom, computing autonomy. I think this is important for archives because it means that the community values doing things the right way and really transparency through the whole process, and also trying to rid ourselves of any of these binary artifacts. It's also based on computer science theoretical work on functional package management, which helps us really capture the whole scope of dependencies, and also cool things like installing multiple variations of the same software simultaneously. And all of this is implemented in GNU Scheme, a general purpose programming language. So each package gets a programming language object that you can work with. So let's look at some of that code. So here's an example software package I wrote that it's a little wrapper script to help me with the multi-factor authentication system at Duke, make it nicer for me. It sort of looks like a bunch of fields you fill in. It is. Scheme has this nice property of programming and data being a little bit interchangeable. On this slide, on line 10, we can see a cryptographic hash, so we get the same bits. As we go down, we see a little bit more of how you might use programming in the package definition. Here in 7 through 11, we name things, a great programming concept. Some of the importance for the implementation being free and open source software is that in the future, we think it might have to be adapted to the system. And so here in lines 3 and 4, we're adapting Milo script to work in the Geek system. And in 7 through 9, we're capturing external dependencies. And of course, we have metadata to help with discovery. There are other solutions out there. They're great, emulation as a service infrastructure, other container systems, just work package managers like pip, but they pull in the outside world. And
sorry, Jack.
Yeah.
Jack, we've run out of time for your talk. Right. If you could wrap it up and hit the Slack.
Yeah, we have a time machine, but Geeks is from the outside world, so let's look out there for future collaborations. Thank you.
Thanks, Jack. Important Code4Lib milestone, first overtime talk of the day. So we got that out of the way early. So good. That doesn't mean it will be the last overtime talk of the day. Maybe. I hope not. I hope yes. No, you know what I mean. Oh, and I still need to look at my computer to tell you what's up next. Dre, you know what you are doing. You're a professional. You've done this many times before. Amy Zhang and Brian Haley converting Excel files into XML, 2 ways explained, 15 minutes on Zoom. All right, take it away, Amy and Brian. Thank you.
Thank you. Can you guys hear me okay?
Yes.
All right, great. Thank you so much. Well, thank you for the opportunity. Today, we're going to be presenting on converting Excel files into XML, 2 ways explained. Before we get started, just a very little background of where we're coming from. We're from University of Laverne, which is a small liberal arts school that is about 30 miles from Los Angeles. We are a private institution. We have about 7,000 students. So you can see we're not a big school. As a result of that, I envy a lot of you can work full-time on programming. At my institution, we do not have a full-time programmer. So My name is Amy Jiang. I am the head of emerging technology and digital initiatives. So I oversee the integrated library system and a lot of other library systems. But because we do not have a full-time programmer, oftentimes we cannot do a lot of amazing programs like what you guys are doing. But last year, we were able to recruit a few very, very talented students who are majoring in computer science. And I list them here today. Some of them are not able to make it today, but Brian Haley, Sean Costello, and Matthew Ball, all of them are computer science students who contribute a lot to this project. I don't know if Brian is able to make it in. Okay, yeah, he might run into some technical difficulties, but this is our entire project team. Now, a quick background of this project. So I don't know how many of your libraries have adopted the Explorer system, which is an inter-institutional repository system developed by Ex Libris company. If you look to the right of the picture here, oops. So it is kind of hub to capture our faculty profile and their intellectual output. For example, their publications, their artworks. So during the early migration time, we learned that in order to feed into this Explorer system, we need XML. Now, I bet a lot of your library use Alma system, which is the integrated library system, and Primo. If you think back in the implementation time, all we have to give the company is an Excel file, and then they will do the conversion. But because for Explorer is a comparatively new system, we have to provide the XML. And now, you know, like we don't have a programmer and I don't do deep programming. So we need to figure out a way how to convert XML into how to convert Excel into XML, because that is the data we collect. So in detail, so if you look at on the right of the picture here, we have a data source, which consists of Excel files. And then if you look at the bottom right, that is the XML file that we will need to generate to send to Ex Libris company. So in detail, so you can see the first row is the header, which is the value of the tag. And then the second row, and imagine there's multiple rows. For the simplicity of this project, I just list one row here. So that is the email, what we need, and then the photo URL. So the goal for this Excel file is to convert it into XML, load it into system to update the photo URL field of the public profile. And then you can see here the XML file. I bet a lot of you are very familiar with it. You can see a lot of them are hard coded, like the first line, the user line. The only sort of variable here is the value here. I mean the email here, and then the photo URL here. So that is what we need our program to generate this two dynamic field. So we considered two ways. Because when I work with a few students, all of them have strengths and the preference in terms of which program they want to work. But interestingly, when I shared first project, and then one of our students, who is Matthew Ball, he said like, "Oh, this is easy. Why you just don't do it in Excel?" I was like, I know there are some functions in Excel, but I don't really think Excel can do such a level of XML generation. But in about 5 minutes, he showed me the result, which kind of triggered today, like I submit the proposal for this presentation, because I don't know if there's a lot of other small libraries who do not have a full-time programmer. In Excel way, you almost can generate an XML file for some specific field without knowing anything about the programming. But then, of course, we have a couple of other students who are strong with programming. So we basically take on this project in two approaches. So first, I'm going to start with the Excel function. So if you look at the screen here, on the left is all we know. Everybody know here, right? Like is the column, is the header, and is the value. But then if you look at on the right, this is using a function which let me explain here. Okay, so the function we use is called concat. Like I think a lot of us use concat before, but what I learned from what my students showed me here is like people like we want to be creative. Like I know the concat function, but I just didn't expect I'm gonna do such a complex level of concat. So basically the step one is to put just manually type the XML header on the top row, which is the like XML version equals to, and then use the concat function, which is the static code, comma, like and then the variable field, and then the static field. So you just continuously doing this, and then you will repeat this function for every row. And then at the end, you put the closing XML tag there, and then you can copy. And then after you have done everything, you just copy the entire column, not the row, entire column of that function, the concat function field. And then you save it into the Word, you paste it into the Word document, and then you save it as text file. Then that is what you see on the right. That is a XML generated. So it is a pretty straightforward process. But there are some pros and cons as we go further on this. The pros is really like initially I was doubting my students, and in 5 minutes he proved like he did it. So it's really fast, and there's no coding required, and everything happened in Excel. So we don't really need any external application. But the cons is complex field that would be hard, and then you would have to do some visual basic VBA coding in XML. In Excel. For example, in education, like a certain faculty have the education, let's say bachelor degree in a certain university as a certain year. So for that, either you have to have a very long concat like function, or you do a VBA, which will make it a little bit easier. So that is the con. Like so, the very basic field, for example, the photo URL, the keywords, you can use the XML, the Excel approach. But for the complicated field, you might have to do a little bit of programming. And then the programming approaches. So because we have students who prefer different kind of languages, and so we actually consider two approach. One is the procedural approach, and the other is the object-oriented approach. So for the Python approach, it's compared. I would consider it's a lot. Save a lot of time compared to the object-oriented approach, because we don't need to define the data types, and then we read Excel entirely directly, and we generate the XML directly from Excel entries. Versus for the C# language we use, our student created the objects, the data types, and then serialized objects into XML. So So that is the two approach we take with the programming approach. I'm gonna go over very quick since I think I think all of you kind of know the programming approach by heart already. Maybe you think it's very simple, but for me, like when our student produced the code, I was very, very impressed with what they are able to do. So Brian was not able to join us somehow still. So I'm gonna kind of talk about his part. In the C# code approach, basically he created a class, users, research. And then if you look to the right on the there are a couple of links here. So these are the documentation provided by Ex Libris company. So we use that to generate our classes, the data type. And then And then this is the basic kind of control flow. So you convert the converter class, generate list of users, and then parse the Excel, and then construct user for each entry, and then export it and convert it into the XML. I won't go a lot detail here, but we have the presentation on the online, so you guys can kind of look at it in detail. The pro and cons for object-oriented approach is really, the pros is really separate the conversion process into distant steps. For example, parse the Excel entry, build the user objects, and then it's laid a very solid foundation for future growth. So in the future, if you want to do add more, for example, we want to do multiple field update, the object-oriented approach set up for a very good start. And then it creates convenient times for data validation, because when we all of us know, like when we have an Excel file in batch, there is, for example, the null value, there's many different kind of exceptions we need to handle. So the object-oriented approach can handle those kind of data validation easily. But the con is require more upfront development time. And then I need to handle very complex data types. So Brian is one of our students who love like putting all his brain power into this project. Eventually what he developed, like I consider it, I was like, wow, this is so complex. It's so different from what I thought, which is later I'm gonna show you guys the Python way. But what he have done, I think, is a very great starting point for us to build further to handle complex data types, to handle dynamics updates. So that is the object-oriented approach. With the procedural approach, let me see how much time I have. Procedural approach in Python is comparatively easy. Like very quickly, our students was able to write the code for me in a few, like just 3 or 4 days. Basically, he started with 3 lists I need, and then he read the whole Excel, looping in the Excel, and then remove the null values, and then generate a template list, and then boom, we have the XML. So this is the control flow here. I won't go very deep in that, but the pro in this is require less upfront development time and less complex code. But the con is really when we want to later on add more multiple field update, he almost have to rewrite the code. So we do see if you have multiple field complex data types that you want to handle, maybe object-oriented is a good approach. Now, there are some limitations. Without the code table, the field that can be updated are limited. And we use the email identifier. So if other school want to use this, you have to decide on which identifier you use. And then we also we want to dynamically generate XML tag in the future based on the Excel data source. So that is something that we want to work on. And if you're interested to just get the code, oh my goodness. We put the our code for the C#, for the Python, for the Excel, all on this page on the GitHub. Feel free to take a look and then contact us for any questions. And we really want to have, like, if possible, any of you are interested, we can work together on this project, because I can see in the future, many other institutions who adopt the Explorer can benefit from this project, because they can just provide the Excel file and use this program to generate the XML file, so that they don't need to go through the pain that we have to go through. So anybody interested, feel free to contact us. Thank you so much.
Oh, hey, right on time. Thank you, Amy.
All right, thank you.
Okay, up next, we have our first in-person talk of the conference with Margaret Heller, Eric Pettiplace, and Billion Kim, the fickle, the federated, the frustrating library search experiences. Oh my goodness, I can relate to this. 20-minute talk, thank you very much. Take it away, folks. Oh, you probably need a microphone. Here, have a microphone.
It's intimidating being the first real speakers. Go gentle on us. Am I holding the mic right? This is good. Candy bar. This is our first slide. It's called C Drive.
Okay. Hi, everyone. I'm Margaret Heller. I'm Digital Services Librarian at Loyola University of Chicago, and I'm going to get us started today. Let's see. Okay, so the three of us have known each other for about a decade, and we've come up in the library technology world together. So we've seen a lot of things change, and we have an idea about where things might be going in the future. But before we talk about that period that we personally experienced or hope to experience in the future, we want to show how the history of library search leads to our current and future reality. This is a very brief overview. We'll definitely share some stories in the chat later. All right, so beginning in the 30s and 40s, scientists and librarians started using punch cards developed for business systems to index literature and automate library systems. There was a big military impetus, of course, with World War II and the Cold War years, and this created a push to increase funding for scientific research, which led to the creation and expansion of federal funding agencies and associated funding for solving problems of information retrieval at the scale required for military purposes. At the same time, libraries were experiencing unprecedented growth. Massive increase in college enrollment led to an expansion of funding and new facilities. The 1960s brutalist buildings so many of us work in are part of that legacy. New buildings, more students, and expanded collections made it necessary to explore automation. So this is a really rough process chart. Don't take all this literally, but this is basically how the pre-automation or pre-computer version of this worked. Documents would be indexed on punch cards, with each punch representing an index term. Combining index terms would physically indicate which cards met those criteria, and you could write down the list of documents relevant to the search and find them in the library or the file drawer. So computerization began in the mid-1950s. And at first, it really only removed some of the manual steps, but was largely the same process, particularly because computers were very slow and not available to most people, and certainly not at any time. But computers had advantages in that they could be, for example, programmed to print out the document titles rather than having someone type up a list. So online search became this a new way of being able to do searches in real time from between a terminal and a mainframe. So improving these processes and using all that funding I just mentioned, many institutions ran experiments in the 1960s and early 70s to create prototype online search systems that would take advantage of new technology to run searches in real time. This is just one quick example, Project Intrex, which was sponsored by a number of private and public agencies and based out of MIT. So this system was experimental. It was designed to find the balance between user needs and economic feasibility of the computing capabilities of the time. So you wanted to index just enough to make it useful, but not too expensive to run. This test database was 15,000 documents in material science and didn't actually use a controlled vocabulary, which made it very different. Another major difference is this system actually allowed full text document retrieval via mechanized microfiche. So back in 1968, you could do full text document retrieval. Experimenters found that users often didn't read the instructions, assumed the computer would naturally understand what they were thinking. And we'll talk more about what that led to later. So online search made it possible for the first time to construct a search, get results more or less in real time, even at a distance, and be able to view them on a display. But the limitations of computing in this period required the kinds of intensive indexing and advanced search features we think of as required for expert searchers today, even though the technical limitations are not actually there in the same way. All of the advances meant that it was, for the first time, much easier to get comprehensive access to relevant resources. So there's issues of scale that pop up pretty quickly here. You can see all this specialization doesn't really scale, particularly for institutions without their own computing facilities. So the MARC project at the same time created standardized machine-readable bibliographic data that could be essentially managed by a consortium that supplied the computing power, which we actually still have today. But the collections that libraries were automating with MARC were largely books and journals. The technical literature was in different files, organized in ways unique to the discipline or original indexing method. The two types of data were separate and largely still are today. And Eric will talk about more of that in a minute. So there were systems that were created to combine multiple files and create unified citation lists across all those disparate systems. So Dialog was started out of experiments at Lockheed in the early 70s and later grew into a commercial service that helped address these problems. Expert searchers still had to know all the differences about what was happening in each file, but could create robust, comprehensive sets of citations. Online search services were very expensive, but allowed for real-time access to very current information. And so we come now to the early 90s, right before the World Wide Web came on the scene. So the information retrieval landscape was largely bifurcated between expert searcher systems and the beginning of end user systems. There were more than 4,000 databases available, some of which were available in all databanks, some only in one, and there were some niche databases for specialists. So online search was the domain of the expert searcher due to the high cost, but it was an expectation that that service would be available, even at the reference desk by the mid 80s. So the divide between cost and convenience for users shifted as offerings and technology changed. So OCLC, for example, had Epic for expert searchers and First Search for end users. CD-ROMs made it possible for users to directly search databases without a cost per search. For areas that were less time sensitive, balancing the offerings between online search or CD-ROMs could help libraries control costs. But as the web became more available, gradually databases started to migrate there, though the traditional online systems were still available. And now I will turn it over to Eric to pick up the story when we come into the web era.
So let's jump forward to the 2000s to review approaches to search and discovery from the past 2 decades as the internet starts to dominate information exchange. Margaret left off with search tools being accessible for end users, moving from CD-ROMs to online databases, but libraries had no unified search interface. They offered a library catalog of bibliographic records and suites of additional resources with their own independent metadata, searching faculties, and distinct appearances. Abstracting and indexing, or ANI databases, are an interesting use case here in that they collect citations from many distinct publishers in one place, and as such were valuable as a research starting point, despite not containing full text themselves. In a way, by digitally recreating print indices, they anticipated the discovery layers that would come later. How did libraries present disparate resources to patrons? Tab search boxes made it convenient to perform more focused keyword searches, but numerous tabs also overwhelmed the user. Tabs might overlap or interact with different levels of granularity. For instance, searching databases versus journals versus articles in a particular database. A to Z lists presented all of an institution's resources in one place, but vendor names like JSTOR and Research Library are uninformative for most users. And even at small institutions such as mine, the lists are of a cumbersome length, and that's only about half of ours. So. The next major innovation in library discovery was the creation of federated searches that take a keyword query and repeat it across numerous different resources, saving the user the trouble of retyping a query and perhaps guiding them to the most appropriate database. But federated search is inherently limited. Vendors do not share metadata schemas or search APIs, so usually only naive keyword queries are supported. Little context of the results is shown. We might see that EBSCOhost has 1 million results and Scopus only 1,000, but we would have to click into each database to actually see what the contents of the resource are. Discovery layers were a natural progression from federated searches. They use a single unified index to present results from multiple content providers alongside one another. They have to map metadata records into a shared schema and deduplicate them, but it enables them to present facets and filters that interact with records from different sources, including the library catalog. However, I've described the promise of discovery layers more than their reality. For a number of reasons, their indices are incomplete, not all records are deduplicated successfully, links to full texts sometimes fail, and any metadata mapping risks losing some nuance. Coming shortly after the initial wave of discovery layers were the first bento box approaches to search and web design. These interfaces are typically handcrafted by library developers and utilize various APIs to show results from multiple systems in parallel. In a way, the bento box is the progeny of the tabbed search and federated search. It pulls from disparate places to execute all the tab searches at once while presenting only a few results from each and offering the user a chance to wade deeper in a particular direction. I wouldn't characterize the bento box interface as a regression, but I find it significant that one can see the underlying silos in its very design. We're witnessing a trend that's culminated with the bento box's visual admission of its internally divided nature. For decades now, libraries have layered progressively more abstractions on top of mostly the same base content. Metadata in dozens of formats representing every conceivable type of media are filtered through almost as many APIs and standards where they can be used in tabbed or federated user interfaces. Then discovery layers try to unite all of those records only to have their own API used in yet another search conglomeration. I believe that is a fire alarm. My talk was so hot that it just, we gotta go.
Hello, YouTube. We are back in the building. Hopefully, can you check Slack to see that people are actually hearing me? Okay. So we're back in the building. Our plan is to have the in-person presentation that was in progress complete. And then we are going to skip the 3 Zoom talks, and hopefully the Concentra folks are contacting the speakers for the 3 Zoom talks from this morning block to see if they can present during the lightning talks block of time. And then we will skip to our last presentation before lunch, which is another in-person presentation. So we're going to finish the one that was in progress. It was in person, skip to the next in-person presentation, break for lunch, fix the entire world, and can then come back.
We're all good? Okay, nothing happened. We're right back with it. So what I was just finishing up saying was basically talking about how all of these technologies and different systems and standards are increasingly just incorporated into this chain of abstractions that we utilize, such that things, even like a discovery layer, are not really the final endpoint. They eventually get reused in things like a bento box interface. So other than this layering, what trends do we see from our modern search experiences? First, the desire for comprehensiveness is a through line for the progression of our interfaces. We're trying to provide an unfathomable amount of information with as much immediacy as possible. Second, the sheer quantity of published materials is a central challenge. The mass of information is the root of so many difficulties, bringing older records into alignment with new ones, deduplication, broken connections between systems, understanding and auditing complex search algorithms. At lower scales and in specific contexts, these problems are addressable, but less so across all of a given library's resources. Larger libraries struggle just as much because while they have more labor and funding, they also manage more resources. Third, despite our best attempts, we have yet to escape disjointed user experiences. As one dives through the layers of abstraction, the murky seafloor of the content's final location is wildly variable. Subscription databases present their own sharing and citation tools, display templates, and what's worse, they have search inputs that are disconnected from and function differently than the one used to arrive there. It strikes me that most libraries still maintain interfaces from all of the stages I've outlined. Tabbed interfaces, federated searches, and A to Z lists are still common. What does it say about libraries that we present our users with decades of interface developments like an evolutionary tree, but with living geriatric organisms? It says that we think there is some value to each approach. It says that we have not and perhaps cannot escape silos. It says that we cannot let go. It says that there are political divisions within our organizations. It says that innovations in discovery will likely not suture old wounds, but apply further bandages.
All right, so following Margaret and Eric's overview of the past and present of library search, I will be talking about the future of library search a little bit. So today's web scale discovery at library is a huge improvement over the past federal research. Of course, it is not perfect. So, and the problem shows up if you have a large and diverse collection. So the larger and more diverse a library collection is, the more ways there seem to be for search results to miss the mark. So this point is easily illustrated by my search for heart attack. And this search brings up as the top result a video DVD in a foreign language, followed by 2 audio CDs. And of course, savvy library users will be able to overcome this by narrowing down discipline and subject. But the point that I'm trying to make here is that returning search results that are understandable and manageable to users seem to be still a tall order for library search. And the internet search engines like Google seem to be doing a better job at this. So if I run the same search, the results bring back the results that come back seem to capture several common search contexts that are appropriate for this particular search term. But what we need to understand here is that when you have a library collection whose materials are diverse in formats and types with limited metadata, capturing common search context for those materials is a lot more challenging compared to when what you got is just lots of web pages, flat web pages whose content is 100% machine readable. So what is the future of library search going to be? The first trend that I notice is that library search is going to have more and more analysis and visualization incorporated. So I'm seeing vendors and context providers are adding more analysis, analytics, visualization, and text mining tools and related features into their platforms. The examples of this include HathiTrust Research Center, ProQuest Text and Data, Mining Studio, and the Code4Lib by JSTOR, and the Discover. The second trend that I see in the future of library search is machine learning. So you can use machine learning in order to add more granularity in search and discovery, and by applying various machine learning techniques and creating machine-generated metadata, which you can see as an example, this AI Explorer website by Harvard Art Museum. So there are various approaches that you can take in order to add granularity in search with machine learning, which includes, search by machine-generated text or visual similarity search. If you have a lot of image materials, that would be one approach that you can take. If you have lots of AV materials, you'll be a lot more interested in speech-to-text, name the entity recognition, audio segmentation, and so on. If you got lots of text materials, you'd probably look at natural language generation and natural language processing for summarization purposes. If you got lots of tabular data, your libraries would be interested in extracting structured data out of that. And if you have lots of materials in non-English, foreign languages, you might want to look into cross-language search, and machine learning can help with all of this. The third trend that I see in the future of library search is critical engagement with information. And this is actually not a trend that has been already established, but this is something that I think is important and something that I would love to see in the library scene in the near future. So libraries constantly wish library search to offer search experiences similar or equal to that of internet search engines. But while doing so, we often forget that the goal of library search and discovery is actually quite different from that of internet search engines. Commercial internet search engines commodify information. So presenting one seemingly definitive and authoritative answer to every search is in their interest, even though that may be far from truth or reality. By contrast, library search aims to inform and educate. Hence, library search can be designed differently from internet search engines with a view to engage people in questioning and investigating first, any given information. Second, the manner in which it is presented through the search result display. And third, how that manner further shapes and influences people's understanding, judgments, and actions instead of simply accepting given information as it is presented. And there are a number of strategies that you can utilize for this. And the first, one of them will be offering both macro and micro view. The other might be exposing relevant but hidden factors for contextualization. So one example of this is the Imagine engine proposed by Sophia Noble in her book, Algorithms of Oppression. Here, the search result is presented as a whole, and the content is marked by different colors, such as red for pornographic and pink for entertainment, and so on. So machine learning can help with visualization at a large scale like this, and also clustering content in various ways. So that's all I have. So I hope the 3 future trends in library search that I have mentioned here are interesting and useful to you. And here are some references, and thank you very much.
Night shift, automating copy cataloging, 10-minute talk. And then after that, we will have some announcements, and then we will break for lunch. We are trying to get the Zoom talks that we missed from the fire alarm rescheduled. So updates on that later. All right, whenever you're ready.
Hi, my name is Tomasz Kalata. I work in the cataloging department in BookOps, which is a shared technical services organization of Brooklyn Public Library and New York Public Library. And I want to talk about automating copy cataloging today, our experiences creating and running a copy cataloging bot. So when we close our doors during the pandemic, as any other library, we rushed to provide electronic resources to our patrons. To speed up the process, we decided that we're going to abandon copy cataloging service provided by OCLC and switch to free vendor records. Our vendor is Overdrive. This allows us to load quickly records, but they had a lot of imperfections. We had problems. They didn't have Library of Congress subject headings. They did not have any standardized access points. They had all kinds of problems. So very early on, it became obvious we need to do something about it. But 160,000 records created a challenge. We couldn't do it manually. We had to create some process that will do it automatically. So we began to brainstorm how we can search WorldCat in programmatic way, how we can edit records with code. That's how Night Shift was born. Just quick overview how it works. So vendor records are extracted from ILS, from library catalog, using a module. We use Sierra, so we use scheduler, which allows us to run daily SQL queries and output records to an SFTP server. Records are then picked up by Night Shift, the application. It parses useful information from them, like ISBNs, LCCNs, vendor identifiers that could be used later to query WorldCat. And to query WorldCat, it uses OCLC metadata API. If a positive match is found in WorldCat, record is manipulated by the app and then serialized into MARC21 and put back into SFTP, which doubles as a network drive from where our catalogers can pick it up and load it back to our system, overlaying the vendor record. In cases when the WorldCat search is not successful, records may linger in Night Shift database. We tried to search a few times before the program gives up, but there is maybe delay between the initial search and subsequent searches. So to mitigate that, Night Shift can communicate via BPL and NYPL middleware to check the state of the record, if it was deleted, suppressed, maybe it was upgraded by one of our catalogers. This is basically the same, maybe more linear view of the same process. I mentioned this before. The records are queried multiple times until the program gives up. Each material type has its own schedule. So ebooks are queried not that frequently. We consider this process for print materials as well, where the schedule may be tighter, makes more sense. Those records get updated in WorldCat more often. Where was I? It's better than fire alarm. So in addition to the query part that utilizes that reserve ID number, there are limiters or filters set in each request, such as results should be only English cataloging only, item type, item subtype for set correctly for particular resource we're looking for, and through experiences we had to exclude certain organization that contribute to WorldCat because they records were pretty bad. There is a link on the bottom if you would like to learn more about the API itself. So it's pretty good documentation. Oh, so this is a URL encoded request for an ebook. Not sure that everybody will be able to see that, but in blue, basically that's a search, index search for reserve ID. We excluded, we set very low bar for encoding level of records. I'm not sure you're familiar with this term, but basically it determines the fullness or quality of the record itself. We set this level pretty low because a lot of records in WorldCat are miscoded. A lot of records have a level M, which indicates batch load process, but they pretty much full records. We did not wanted to lose them. The order, I forgot to mention, is also important. So we just made the assumption that most widely held record in WorldCat will be the best. That may not be always true, but in general, it's a good strategy. So after obtaining a record from WorldCat, we cannot really accept it as is. And our copy catalogers massage those records before they are imported to our catalog, and Night Shift does the same. So certain mark fields are removed. There is a cleanup happening in 600 tags where program removes terms from vocabularies that are not supported in our catalog. It removes 856 tags, which contain URLs to the actual resource, and replaces them with the data from the vendor record. And this is just so we don't link in our catalog to resources we don't really have access to. Finally, Night Shift adds various local fields, call number, sets some commands for facilitating import of the records. If needed, it adds some local genre headings. And this is the result of this enhancement. We were very happy to see that subject headings are more granular, the LCSH subject heading fast, etc., instead of terms that are just relevant to overdrive. We were quite happy. We were not expecting to get 100% rate, but 90,000 out of 160 was a pretty good number. In general, we had a good rate for English ebooks and e-audio, word language materials, and video provided by the vendor had dismal results. Yeah. So a little bit about the technology under the hood of Night Shift. I guess most of those libraries are well known. We developed also some additional packages to wrap the OCLC metadata API in a package that we call BookOps WorldCat. We have our own sweetened PyMark fork that understands our records. But overall, that's not much. The database is a Postgres database. What we did novel was that we included, I'm not a programmer, so we included the code review in the development process. That was something new for me. And we found a good seasoned programmer in our library who did that, volunteer for the work. Thanks, Mike. And that's it. If you want to see the code, there's a GitHub repository. Feel free to reach to me if you would like to hear more. Thanks.
All right, we have made it barely by the skin of our teeth through the first half of the first day of the main conference with only minor mishaps. So thank you everyone for your patience as we wrestle with technology and inexplicable fire alarms and the like. Big shout out to Carlin for their unflappability. Big shout out to Omar for making everything work. And other AV folks, thank you.